So, welcome to the simulation of triple server queuing system for a call center. In the simulation, we are going to see the inspiration for the simulation, a design of the model, and the outcomes, what we're going to get from the simulation of this model, the simulation of the model itself, and the descriptive statistics of the model. Now, let us see one by one. So the inspiration for this model came from the terminologies of single server queuing systems and multi-server queuing systems. And often in our day-to-day life, we often see we wait in a queue for a hot dog, and eventually we go for an airport and we wait in a queue for a check-in as well as security. Also, we go for a checkout for grocery store, and also we call for a Amazon Prime. I mean, we come with customer service for Amazon or eBay or for any customer service. From all these, when we cluster all this, what we can found is, we can common terminologies like calling population. That means how many number of customers are calling in a particular amount of time or a day, or a waiting time, how much time you are waiting, and service times and how much service times your problem is going to be solved, and the inter-arrival times. That means how many people are coming in around a range of 5 minutes or 10 minutes or a day or a week, and a departure time, at what time your service is completed. So these are all the common terminologies we often see in any queuing system. Um, Queuing system. Let us see the design of the model. So let us coming to the design of the model. The current project proposal is basically a service provider which will take a calls from persons and provide service. And here the three service providers are named as Ram, Sam, and Tom. And coming to range analysis, your customers arrives randomly at a range of X to Y minutes. Let's assume that it's like 1 to 4 minutes or 2 to 7 minutes or any range, and the service times are randomly generated. Service times mean the amount of time that they take to solve your problem. Let's say maybe 5 minutes, 10 minutes, or 1 hour. It doesn't matter. It is just service times. So it is the design of the model. You can see here the design is as follows. If the Ram, Sam, and Tom are free, then the service goes to Ram. The first customer is given to Ram irrespective of any irrespective of anything. And if the RAM is busy, then what? Then service goes to Sam. Sam will provide the service. If both Ram and Sam are busy, the service goes to Tom. And finally, if all the three are busy, then the customer has to wait for one of them, which server which complete the service first. Then the next customer will be assigned to the particular server. That's why we design this model. Now let us see what are the possible outcomes if we design this model simulation. So we design this model for any number of customers. You can give 10 customers or 20 customers or 100 or 1000 or 10,000. It doesn't matter. We will see the inter-arrival times which are randomly generated. Through inter-arrival times, we are going to calculate the arrival times through cumulative addition of inter-arrival times. And for each server, Ram, Sam, and Tom, depending on the weight the task goes to, we can see the different parameters like the time the service begins, the time service ends, and the service times for each server. And also we are going to calculate the caller delay. Let's say, for example, if one of the server Ram, Sam, or Tom are busy, the customer has to wait before being served, and the time gap is nothing but a caller delay. And at the end, we will also see the total time spent in the system. Moreover, we are going to see how many number of calls taken by each server. Let's say for 10 customers, 6 customers are taken by served by Ram, and the 3 customers are served by Sam, and the 1 customer is served by Tom. And also we are going to see average time spent in each call. Let's say like 5.2 minutes for Sam and 4.2 minutes for Ram, and just 6 minutes for Tom. This is the average time. And also total time spent in each server. So for total time, for example, if you simulate a model, so how much total time taken or spent in the system, in the server Ram or Sam or Tom. So these are all the outcomes we're going to see if you simulate this model. Last but not least, we're going to see a text-based simulation of this model. Now let us go to actual simulation of the model. So this is actually the Python code written for our simulation. This is the Python code. Now let us see the simulation. Now let us give let us simulate for 10 customers. Later on we will expand our model. 10 customers, so interval time of 1. I'm giving the interval 1 to 4 minutes. And now again the minimum service time is 2. Let's give the max service time of 7 minutes. And there you go. So our model is simulated. The first service is taken by RAM, which will service begins at 0th minute. The service time is 3 minutes, and you can see here the service time is 3, and the service completed 3 minutes. Total time spent on the system is 3 minutes. Again, the second server is RAM, and the third service is SAM, and also you can see the service taken by Tom also. Now you can see here the descriptive analysis of this model. Total calls taken by RAM is 6, total number of calls taken by SAM is 3, number of calls taken by Tom is only 1. Total calls of 10 as we are given the number of customers. And also here you can see the number of maximum time spent in the RAM is 5 minutes, maximum time spent in the minimum time is 2 minutes, average time spent in the RAM system is 3.6 minutes, and total time spent in the RAM system is 22 minutes. And the same concepts are applied to SAM and Tom. And also you can see here total time spent in the entire call history is 35 minutes for this simulation. Now let us check for another more customers. Let's give some around 100 customers. Let's change the interval of time. Let's say minimum is 3 and maximum is some 7. Minimum is now give 3 and maximum is like, let's say give some around 8. Give some 9. Now there you go. Our new simulation is as follows. So here again the service time, the server completed caller delay, and you can see the same simulation as follows. And also here you can see the number of calls taken by RAM is 62, the SAM is 34, Tom is 4, and number of calls taken is 100, and again the rest of the thing is same as we have observed in the below. Now let us change again the new give customers of, again just change the customers time 1000. Minimum time, let's say give around like 2 to 7 minutes. Let's give increase the service time. No, decrease service. Let's say give service time only 2 to 8 minutes. 2 to 7 minutes. That's it. Don't increase more. And there you go. And the new simulation is as follows. And this is for 1000 customers. And you're going to see here the server simulation. However, you're not going to see much of caller delays. This is the actual simulation. Let us see the analysis of this model. You also see the total number of calls taken by RAM is 647, 3119 by SAM, 34 by RAM. The same, the analysis is the same as follows. Now let us see the descriptive analysis of the model. Now let us see the descriptive analysis for triple server queue. Okay, so now the first descriptive analysis is taken by the first observation. What we have found from the example is proposed number of calls. So here the number of calls taken by each server for different number of inputs. Here the 5 calls, the 25 calls for 1000 calls. Server is RAM, SAM, Tom. So the observation 1 is, so if you see here, if there are 100 calls, the number of calls taken by RAM is 44, and for 1000 calls, number of calls taken by RAM is 471. And you can observe here the proportion, the 44, 471. It's really a proportionally good number. And also if you can see here, if there's 25 calls, the number of calls taken by RAM is 12, the number of calls taken by, if there is 250 calls, number of calls taken by RAM is 112. I think there is a proportional number of calls. So we can assume that model is definitely in a good shape. Now let's go to another observation. So you can see here, the number of calls taken for 1000 calls, number of calls taken with different interval times. Now here the observation is defined for 1000 calls. So the observation what we found is, if there is interval of time of 2 to 4 minutes, and if you compare with 7 to 11 minutes, here the number of calls taken by RAM is increasing, but the number of calls taken by other two servers are decreasing. If you see the Sam, the number of calls taken by Sam is decreasing, and if you see Tom, is almost zero. So what the observation found out is, if the inter-arrival times are increasing, number of calls taken by only the first server, there is nothing but a RAM. Now the observation, go for observation 3. So the same observation is designed for 1,000 calls. And if you observe here, the service times are increasing. Number of calls taken by first server is decreasing, and the number of calls taken by the next two servers are increasing. And you can see the graph here. Initially, the number of calls taken by RAM is very low, almost like 3. But here, if you go for increasing from 6 to 12, it's almost like 200. And if you expand this service times, obviously Tom will reach the top. Now let us see the highlights of simulation. We have seen the different examples of queuing systems. We have seen the design, the outcomes of the model, and even the simulation of the model itself. And also we have seen the descriptive analysis of the model. Hope this simulation give you the overall picture of a queuing systems, especially triple server queuing system. And thank you so much